The companies involved in the experiment, in alphabetical order: Elon Engineering Industrial Weighing Systems, Overload Prevention and Force and Load Measuring Systems, Israel; Teichman Lighting Design Systems, Israel; Stage Design, Rigging and Stage Technologies, Israel; Sepsis Rigging, Rigging Installations, USA; Y Circus, Aerial Acrobats, Israel. The experiments were conducted with a special system which enables 25 measurements per second. Experiment 1. A mother grid structure was erected. The upper grid was suspended from the ceiling by 4 identical chain hoists simultaneously controlled by one switch. One load cell was hung in line with each of the 4 hoists. An identical arrangement of grid, hoists, and load cells was suspended from this upper grid. In the experiment, a slight change in the weight of the loads on the lower grid triggered a practically incalculable change exhibited by the load cells. Conclusion: on a mother grid structure, any changes in the lower grid load or load distribution will usually change the load values and distribution on the upper grid, which in turn might cause an overload situation. Experiment 2. A structure of 1 truss with 3 loads and 3 hoists. Experienced rigging personnel attempted to level and balance the truss. When using the load cells, we could see that the attempts to balance the truss visually resulted in random balancing and imbalanced load division on the hoists. We also noticed that the slightest operation of one of the hoists, even for a fraction of a second, resulted in the addition of hundreds of pounds, while the truss still appeared to be balanced. Conclusion: a visually balanced structure is likely to have imbalanced load division, and some of the hoists might even be overloaded. Experiment 3. Measurement of dynamic loads involved in an acrobatic performance. The load cells recorded a maximum of 237% of the acrobat's self-weight. Conclusion: significant dynamic loads are involved in acrobatics. Experiment 4. Measurement of dynamic loads involved in lifting a load with a hoist and stopping the hoist's operation. This test was conducted with both 50 feet per minute and 14 feet per minute hoists. With the 50 feet per minute hoist, the load cells recorded a maximum measurement of 180% of the load's weight. With the 14 feet per minute hoist, the load cells recorded a maximum measurement of 120% of the load's weight. Conclusion: dynamic loads exist when starting or stopping the hoist's operation. The faster the hoist, the larger the dynamic forces. Elon Engineering has undertaken to harness our engineers' 3 decades of leadership in the industrial load cell industry to develop and launch a reliable, user-friendly platform to boost the rigger's performance, especially in preventing stage accidents due to overload. We are now proud to introduce the RON StageMaster. The RON StageMaster is comprised of 3 components: the load cells, handheld indicator, and PC software. The load cells. The RON StageMaster load cell embodies the technical know-how and the field experience that has been acquired from the sale of thousands of RON industrial crane scales over 3 decades now. Installing these wireless load cells onto the hoists is quick and easy and does not require adding any messy cables. The load cell is made of high-quality aerospace steel and is available in 2 safety factors, 5:1 and 10:1. It is available in standard capacities of 1 to 6 tons. Higher capacities are available. And in sets of up to 16 load cells per frequency and more than 1 frequency. The load cell shackle holes are shaped to have a 90-degree angle between their axes in order to eliminate external moments influence which might cause inaccuracies. The battery life of this load cell is up to 1,500 hours on common disposable batteries, with optional 110 or 220 volt AC operation. Another distinguishing feature of the Ron StageMaster load cell is its small dimension that provides low headroom loss and easy portability. The handheld indicator. The handheld indicator has an RF reception range from the load cells of up to 450 feet, 150 meters. The PC software. In addition to being the first wireless stage load monitoring system, the Ron StageMaster is also the first to overlay the load distribution map on a grid plan preloaded from programs such as AutoCAD. This easy-to-install Windows 2000 compatible software provides a real-time simultaneous load measurement, including overload and underload detection. It offers user-defined set points for overload and underload detection of individual hanging points, user-defined groups of hanging points, and of the entire structure. Each set point can be used for a variety of purposes, such as setting off an alarm and stopping the hoists using any controller currently available on the market. It is therefore an innovative tool to unburden the rigor of the stress involved in overload prevention without knowing the actual load values and distribution. In addition, from a risk management perspective, the Ron StageMaster may justify Rigger's request for lower liability insurance premium. Here's a summary of the main screens. Settings. Using this screen, you determine which load cell will belong in what group and assign a customized overload value for each load cell. This screen enables you to drag and drop the load cells onto the underlaid grid plan according to their physical location on the structure. This feature enables the rigger to immediately identify exactly where the problem is located on the stage structure. The next screen is used to assign group names to associate the load cells with a group functionality or location, for example, speakers, east upper truss, etc. Using this screen, you set customized group overload values. Weight control. This is the main screen that displays simultaneously in real time load values and distribution map. In addition, it will show important group data such as sum, max, name, tear, zero, and situations such as overload and danger. Reports. Ron StageMaster has a powerful report generator of downloadable data log of months of continuous measurements, as well as all instances of overload and danger that is easily transferable to any database software. Remember the near accident that we showed in the beginning? Now you have the tool that enables you to spot any undesirable load distribution the moment it begins to be dangerous, and immediately take corrective measures by stopping the hoist and, more importantly, using the load map to determine how to best rebalance the load distribution. Ron StageMaster. See it, handle it before it happens.